now we can start to deal with the horizontal and vertical components at 45 meters. So we want to know how long it will take the rock to travel the 45 meters across the moat. And then we want to know at that time what is the height of the rock, because we want to know if it will be able to travel over the 17.5 meter high wall. So, using displacement formula, we have our x bar, or the 45 meters, because we want to know the time at which it will be at 45 meters. And so, using this 45 meters, we will set it equal to 16.69 meters per second times the time, which we do not know yet, plus 1/2 acceleration, which was 0, and we already defined this earlier in the video, times time, which we do not know again, squared. So moving on, we now, since acceleration is 0, we can cross this whole part out, and it's just 0 because 0 times anything is 0. So now we just have 45 meters is equal to 16.69 meters per second times the unknown time. So dividing 45 meters by 16.69 meters per second will cancel out the meters in 45 and the 16.69 and just leave us in seconds. And we will now be given the time in seconds, and it's going to be equal to 2.696 seconds. So, now that we have the time it takes for the rock to cross the moat and hit the wall or go over the wall, we now want to know what the height of the rock is, or the vertical displacement the rock will have. And so, trying to find the vertical displacement, we now take the displacement formula again, but plug in our vertical components. So, we use our initial velocity of 19.15 meters per second times the time we got from up here, finding when the rock will be at 45 meters, what time it will be at. We found 2.696 seconds. And so we will be able to find the displacement, the vertical displacement. So solving and simplifying this whole equation, we will now get 51.628 meters minus this whole part, which is 35.613 meters. And so this will simplify to meters because it's meters over seconds times seconds. So the seconds will cross out with the seconds and just leave us with meters. Over here though, since we have the seconds squared right here, it will be multiplied with meters per second squared and cross out the 2 seconds squared and leave us with just meters. And so, in the end, we will get the vertical displacement to be 16.0198 meters. And since this is not greater than 17.5 meters, our catapult will not be able to get over Holy Cross's wall, and we will not be able to attack Holy Cross.